Right, so our last lesson we're going to look at is Pythagorean Theorem. You can ignore the section. The section is from a different book. I don't think I put the section on your notes. So first thing I'm going to do is start out just by defining what it is. Does anybody know what shape you use the Pythagorean Theorem with? Like to use it with circles, use it with squares? Yeah?
Triangle.
Yeah, you use it with triangles. Okay. And you have a spot on your guided notes. Okay, it says Pythagorean Theorem, colon, and then there's some lines to write down what it is. Okay, so I'm going to give you the definition first, then I'm going to give you the formula, and then I'll explain why I'm giving you the definition first. Okay, so first of all, it has to do with a certain type of triangle. Okay? Pythagorean theorem is used in what's called a right triangle. Does anybody know what kind of triangle that is? What does it mean to have a right triangle? Yeah?
It's a triangle that has a 90-degree angle on one of its corners.
That's perfect. That's exactly what it is. So this is a picture of a right triangle. Okay? And as Gabe just said, it means that you have an angle that's 90 degrees. Okay? An angle that forms like an L shape. Okay? That's how I think of it. Right. And there's two sides in this triangle. Okay? It has three sides. Okay? But we have two names. Does anybody know what you call the longest side in a triangle? Begins with an H. Yeah? Yeah, this longest side, and we're going to write this down again in a little bit.
So can we write that here?
Yeah, what I would do is you got a little diagram. I was going to write it down below, but if you want to write it down, where it says C, and you have a line, on that line next to C, you could write hypotenuse. And then we're going to call these two sides A and B. And they also have names. Does anybody know what you call the short sides in a triangle? We have two of them. We as in people. That doesn't quite narrow it down, but legs, yeah. These are the legs. That's a leg, and that's a leg. All right, so those are the names of those sides. All right, so now I'm going to describe to you the formula now that we have those names. Okay, it says in a right triangle, the square of the length of the hypotenuse. Okay, so the Pythagorean theorem has to do with lengths. Okay, we're measuring how long the sides are. The square of the length of the hypotenuse is equal to something. Okay? It's equal to the sum of the squares of the lengths of the legs. All right, so that's a little confusing, but we're going to go through what that means. In a right triangle, if you take the hypotenuse and square it, and then you take each leg and square it, and you add those two legs that you squared together, it will equal the hypotenuse squared. And I think it'll be a lot easier once I write that out using letters, so you can see what it is. Right, so that says the square of the length of the hypotenuse, so you take however long the hypotenuse is and you square it, is equal to the sum of the squares of the lengths of the legs. So you have to take each leg and square them, but then you have to add them up. Okay? All right, so you guys already have this diagram, and I think you already filled it out. You have sides A, B, and C. Okay, did everybody already label A as a leg, B as a leg, and C as a hypotenuse? All right, so we already got that. And now let's see if we can figure out what the formula is using these letters. Okay, what letter here represents the, let's say, one of the legs? What letter in that diagram represents a leg? Well, Ben? A
or B.
and B, yep. Now let's look at the formula. It says to take the square of the length of the leg. Okay, let's start with that. What do you get if you square what I just circled? Okay, tell me, what do you get if you square what I just circled? This is A. If you square A, it becomes what?
A squared.
Yeah, it becomes A squared. All right. Now it says to square the length of the legs, plural. Okay, so now we have to do the other one. What do you get if you square B? Yep.
B squared.
You get B squared. And now it says to take those two things that Gabe just said and do the sum. What does sum mean? If we're going to take two things and sum them. Yeah, Justin? Yeah, we're going to add them up. So we took the first leg and we squared it. We took the second leg and we squared it. And then we're going to add them up. That's the sum. Okay? And that's equal. Okay, I'm just going to write this down. So the formula for Pythagorean Theorem. And it says that that's equal to the square of the length of the hypotenuse. Okay? Kevin, what's the hypotenuse in that picture? What letter? C. And it says to take C and square it. So what do you get if you square C? It's not a number. It's still going to be a letter. Think just like when we squared A, we got A squared. When we squared B, we get B squared. When you square C, yeah, C to the second or C squared. Okay? There's your formula for the Pythagorean theorem. Okay, so that's what you want to put in that box. A squared plus B squared equals C squared. Now, this time I use the letters A, B, and C. Okay? You don't always have to use those letters. Okay? Let's say I had this picture, and I put X, Y, and Z. Does anybody think they could tell me the formula for the Pythagorean theorem if I use these letters? It follows the same pattern. Just don't write A, B, and C. Use the letters I have here. Yep.
X squared plus Y squared equals Z squared.
Perfect. X squared plus Y squared equals Z squared. Okay? So, important thing to just make sure you understand, you can use any letters you want. What if I took this picture and did that? Would that change how I write the formula? No. Nope. Doesn't change anything about how you write it. The triangle can be turned any way you want. Of course, we'd have the letters right side up. Okay? But no matter how you see that triangle, it's always one leg squared plus the other leg squared equals the hypotenuse squared. Okay, let's try one more like that. Let's try this. Okay, somebody give me a letter, any letter you want. Don't use O because that kind of looks like a zero. Victor, give me a letter.
V.
V. V for Victor, I like it. V. Okay, somebody else give me another letter. Yep. G, sure. Let's put G. And somebody give me a third letter. I? All right, I'm going to do capital I just so it doesn't look like a 1. BGI. So using that diagram, can somebody tell me what the Pythagorean theorem would be?
Would it be b squared plus g squared equals I squared? No, never mind.
All right, I like the v squared.
Wait, I'm confused. Yeah, I don't know.
What side is always by itself right here? Do you remember the name of that? What's the longest side in a triangle? Hypotenuse. You always put the hypotenuse by itself. So you want to try it again, Victor?
So would it be I squared?
V squared plus I squared equals
G squared?
G squared. Perfect. Always put the hypotenuse by itself.
Oh, yeah,
Okay.
I just got confused with this.
Yeah, you can, on the test, I'm going to give you guys a couple problems like this. Okay, the triangle might be turned different ways. It might use letters other than A, B, and C. But as long as you know the pattern, you're all set. Okay. Any questions on the formula for the Pythagorean theorem? All right. A Pythagorean triple. Has anybody ever heard of that before? Pythagorean triple. All right. So on your reference sheet, okay, there's a spot that says a Pythagorean triple is a set of, and we're going to write that down. Okay, Pythagorean triple is a set of 3 positive integers. What's an integer again? Anybody remember what kind of numbers are integers? Negatives, positives, they don't include what? Fractions or decimals. Okay, so we're talking about nice numbers here. No fractions, no decimals. 3 positive integers. Okay, and let's call those integers A, B, and C. Okay, just we'll use the letters we used before that satisfy this equation. Okay, so it's 3 numbers that you can use in the Pythagorean theorem that are not fractions or decimals. Most of the time when you use Pythagorean theorem, you get fractions and decimals. All right, and it's kind of a pain because you need a calculator. But sometimes you don't. Here's 3 special numbers that form what we call a Pythagorean triple. The numbers 3, 4, and 5. Now, you can't just pick any 3 numbers. For example, 5, 6, and 7 won't work. 7, 8, and 9, that won't work. Okay? But 3, 4, and 5 do work. Okay? And let's take a look at y. Okay? I'm going to fill in these 3 numbers in these 3 spots. And you'll see that it does work. Okay? Using the arrows I put, what number am I going to fill in for A? 3. And we're going to square it. What number am I going to fill in for B? 4. And I'm going to square it. And what number am I going to fill in for C? 5. Watch what happens if you do this out. Okay? What's 3 to the second power? 3 times 3. Yep, 9. What's 4 to the second power? 16. And how about 5 to the second power? 25. Now watch what happens if you add 9 and 16 together. 9 plus 16 is 25. Right? So that's called a Pythagorean triple. 3, 4, 5. Okay, Pythagorean triples are kind of hard to figure out. Most of the time, you can't just guess 3 numbers and have it work. Okay? Let me show you guys one more. 5, 12, 13. Okay, I didn't figure this out. It's because I have it memorized. Okay, 3, 4, 5, 5, 12, 13. They're the only two that I have memorized. But there's millions of them. I just don't have them all memorized. Mr. Roy does, but I don't. All right? So let's fill them into this formula and see if it works. Okay? What number would you have to fill in for C? Let's say these were written in a different order. Doesn't matter the order I write them in. You have to plug in a certain number for C. Why do you have to plug in 13 for C? It's the biggest. You always have to put the biggest number for C. Always. Okay? Doesn't matter the order that they write it in. If they write 12, 13, 5, 13, 5, 12, 5, 12, 13, doesn't matter. Always put in the biggest number for C if you're trying to check it. All right? Doesn't matter what you put in for A and B, as long as you put the biggest number in for C. All right? So let's plug in 5 for A, and let's plug in 12 for B. Okay, you don't have this one written down. I'm just showing you one more example of a Pythagorean triple. What's 5 to the second power? Oh, Alex?
25.
Yep, 25. And Sam, how about 12 to the second power, or 12 times 12? Good, 144. And now 13 to the second power. Let's use that calculator because that's kind of big. 169. Watch what happens if you add 25 to 144. What do you think you're going to get? Yeah, if you add 25 to 144, you get 169. That's a Pythagorean triple. Okay? Somebody give me a number. Okay, I'm going to show you something that's not a Pythagorean triple, because if I just ask you guys for random numbers, this probably won't work. Okay, which is what I want to happen. So Ben, give me a number.
5.
5? Okay, somebody else give me a different number. Yep.
30.
30? Woo, going big. 5, 30, and give me one more. What is it? 2? All right. Now, first of all, I could show you guys that you could never even have a triangle with these sides. It wouldn't work. But I'm not going to show you that. I'm just going to show you that this is not a Pythagorean triple. Let's plug the numbers in and see that it does not work. What do I have to fill in for C? Got to put in the biggest number on that side. 30? Now just take the other 2 and put them on the other side. 5 squared plus 2 squared.
So does it matter which one you put for which?
Nope, A and B doesn't matter. The only one that really matters is the one that's on the other side.
How to get the test?
Yep,
First place.
yep. How about 5 to the second power? That gives me how much? 25. How about 2 to the second power? 4? Let's do 30 times 30. 900. Does 25 plus 4 equal 900? No. These 3 numbers right here are not a Pythagorean triple. They don't work. Okay?
So like on the test, we have to solve it after we plug everything in.
On the test, what I'll probably do is I'll give you 4 choices. I'll give you 4 sets of numbers, and I'll ask you which of them is a Pythagorean triple.
Which one is 3?
Yeah, there won't be more than one. Okay, maybe I'll give you something like this. I'll give you another one that doesn't work, and then I'll give you one that does. Okay, and you'll have to figure out the one that does.
Also, there's not going to be like an option like none of them are?
No, there will be one that works. Yep. So, yep, there'll definitely be one that does work. Okay, so we kind of already did it, but let's go through this one. Okay, example 1A. You guys get a spot on your guided notes. It says, find the length of the hypotenuse in the right triangle. After we find the length, I want you to tell me if you have a Pythagorean triple. Now remember, what kind of numbers are you not allowed to have for Pythagorean triples? You can't have fractions and decimals. So if we solve this and it comes out to like 15.7, that's not a Pythagorean triple because it's a decimal. Okay? So we'll go through it and see if we get a decimal. Okay, so on your sheet, you guys need to fill in the lengths. Okay, that's blank. So fill in 12 for the top, fill in 5 for the left. Okay, and we're going to use the Pythagorean theorem. Right. The side that's 5, that's a leg. If we're going to use the Pythagorean theorem, where would the 5 go? What letter could we fill it in for? You could fill it in for A, or you could fill it in for
B.
B. Either one. Let's just fill it in for A. How about 12?
C. Right? Is that biggest?
Is 12 going to be the biggest?
No, hypotenuse.
Yeah, the hypotenuse is always the biggest side. Okay, so whatever side is across from that symbol, that's always the biggest. So that means we have to fill in the 12 for what?
B.
Yep. Fill that in for B. And what are we going to fill in for C? What did they call it in this problem? Yeah, they called it X. You could call it X. You could call it V for Victor, I for Igloo, whatever you want to call it. Okay, they called it X. Right, so let's just fill those in. So I got 5 squared plus, what am I filling in for B?
B.
12, yep. And what are we filling in for C? What is it? Yeah, they decided to call it X. They didn't use C. That's fine. And now our goal is to solve that problem. Okay, if you need a calculator, you could use it. Let's see what we can do out. Davin, what's 5 to the second power? Yep, good, 25. 12 to the second power, I think we did this one earlier. Maria, can you tell me what 12 squared is?
144.
Good, 144. Now, you can't do anything with the x. Just leave it. Okay? Just leave it as x squared. I'll show you in a second how we're going to get rid of this 2. Okay, let's use our calculator and add up 25 plus 144. Gives me 169. Now, we don't have x by itself. Okay, the problem is this little 2. Okay? So this says x squared. Does anybody know the opposite of squared? There's a button for it.
The square root.
Yeah, it's called the square root. Okay, and it looks just like that. All right, so Mr. Ray and I, all year, we talk about do the opposite operation. If you see add, we subtract. If you see multiply, we divide. Well, anytime you see this 2, okay, you're going to use what's called the square root. Okay? And if you do it on one side, where else do you think you have to do it? You have to do it on the other side. So we're going to go like that, and we're going to go like that. And what that does is the square root and the square cancel each other out. That's how you cancel the little 2 up high. You have to use that. All right, so we'll try to make sure you know where that is on your calculator. And now we have to type in the square root of 169. Okay, I'm going to show it to you on this calculator because this is how you're going to do it on the ones I have. Second, and then you press the square root button. And it's just like that on mine. Second, square root button, and then type in what you want to take the square root of. And we got 13. That's the answer. So what we just did is we figured out how long that side in the triangle was, just by knowing the other two.
So
Right?
you pretty much just,
And that's it. That's the whole problem right there.
It's easy.
Yep. Now, did we get a fraction for an answer?
No.
Nope. Did we get a decimal?
Okay.
Then the answer, did we get a Pythagorean triple?
Yeah.
Yes, we did. We have a 5, we have a 12, and we got a 13. No decimals, no fractions. So this is a Pythagorean triple. Okay? What is the triple? 5, 12.
This is a fad, should be.
so pretty much to get rid of the
Yeah.
x squared, you just do what's it called, the opposite of square root.
Yep. Yeah, that's right, triple. Yeah, I thought I put a double P in there. I'll show you one in a second that's not a triple, where we get a decimal.
Wait, is there going to be decimals on this?
Yes. Yep. There'll be some that are and some that aren't.
Okay.
All right, let's try this one. This time, anybody think they can tell me what my equation is going to be? What squared plus what squared is going to equal what squared? And if you don't know the whole thing, maybe
It would be 7 to the second plus 24 to the second equals x to the second.
yes, you always have to put this side by itself. Whatever side is across from this symbol, the long side, right? You got to put by itself. Now we got some big numbers, so let's just use our calculator. Maybe 7 squared we could do. Anybody tell me what 7 times 7 is? Callan, did you say it? 49. Thank you. Okay. Some calculators have a button for squaring. I think this one does. 24. Just press the button to the second power. 576. Okay, what's the next thing I do with 49 and 576? Add them up. I'm going to do 49 plus 576, and I get 625. Now the last step is you got to get rid of this 2.
You do a square or something.
Yep, square root on both sides. Square root cancels the square. Okay, and now we're going to type in the square root of 625. Square root of 625. And I got an answer of 25. Is that a fraction? Is that a decimal? Nope, I got a nice number.
I will.
So, because we got a nice answer, do we have a Pythagorean triple? What do you guys think? Did we get a Pythagorean triple there? Yeah. The Pythagorean triple is 7, 24, 25. That's a new one. I never showed you guys that one. Okay, and it's one that I don't have memorized. Okay, so yes, we have a Pythagorean triple. What is it? It's 7, 24, 25. Okay, but you can see how much work you have to do here. It's really not that much. That's it. That's the whole problem. Okay, and Victor, you asked about some with decimal. I know we haven't done one yet, but I am going to do one with a decimal. And I'll show you how to round it and deal with that.
Is there going to be like a couple of those, or is it just going to be one?
It could be 1 or 2. I'm not sure how many have decimals. I know it's at least 1.
So on the test, like, is there any way to get a partial credit on a problem, or is it just completely wrong?
If it's there's some multiple choice. If it's a multiple choice question, it's pretty much right or wrong. If it's one where you need to show your work, I always give half credit if you set it up correctly, but then make a mistake. But if you set it up correct, if you don't set it up correctly and you don't show your work, then you won't get credit if you get it wrong. All right, so let's try this one. It says, find the length of the leg. What's different about this question than the directions in the last two questions?
Asking you to find the leg instead of the hypotenuse.
Right. You're not finding the length of the hypotenuse. This time they're giving you the hypotenuse. I can already tell you the hypotenuse is 14. They want the leg. So we have to be careful when we set up our formula. Okay, it's going to look like this. Anybody tell me where I could fill in the 7?
A
Yep, or
or B.
B, doesn't matter. Okay, you can fill in the 7 for either A or B. What does matter is what you plug in for C.
Wouldn't it be 14?
Yes. So let's plug that in for A. Let's plug that in for C. What's the only letter we haven't used?
B.
Yeah.
You put X there.
So we'll plug that in for B. Okay, we have to get used. They might not use the letter B in the actual problem. They might use X. A lot of times they use X. So we're going to fill them in exactly like that. 7 squared plus x squared equals, what are we filling in for C? We already have an arrow pointing to it. 14 squared. Any question on why we had to put the 14 in? Why didn't we put the 7? Why didn't we put 7 in for C?
14.
Right, 14 is the big one, right? You always have to put the big one in for C, the side that's across from that little symbol. Right, and now we'll just do it out like the last one and see what we get. 7 to the second power. I think we've done that a couple times now. Alexis, what's 7 to the second power? Yep, 49. Do I do anything with x squared right now? Nope, we just leave it. And 14 squared, I think is 196. All right, what am I going to do next here? Think about, we're trying to get the x squared by itself. So there's something that's next to the x squared that we don't want next to it. Yeah?
Well, knowing how you would get the number, what you would do is you would subtract 49 from 169 and then square root it. And square root
Yeah.
it.
Exactly. So the first thing we got to do is, the goal is to get this by itself. Okay? So you have to take this 49 and we got to move it to the other side. Just like we've done with equations all year. This is a positive 49. What's the opposite of positive 49? Negative 49 or minus 49. Okay. What happens when you do 49 minus 49?
Cancels out.
Cancels out. That's gone. What's the only thing that's on the left side now?
Just X to the second.
Just x to the second. And now I need to do this out. 196 minus 49. So minus 49 gives me 147. And now what is my last step? Because remember, this is not x. It's x squared. Yeah, we're going to square root. Square root. The square root cancels the square. Okay, so x equals, and we'll always use our calculator to do the square root. Okay. Does anybody remember how I type in square root and it's the same way on your calculator? What do I have to press?
Second.
Yep, on your calculator it's going to be the same thing. You press second, and then you're going to press the x squared button. It's exactly the same thing. Right? What am I taking the square root of? What number?
147.
147. Okay, I got 12 point, and I got a decimal.
Sorry.
Does it say in the directions where to round it?
No.
No. So I don't have to pay attention to that. So we can round it wherever we want. I would say let's round it to 2 decimal places. So if I round it to 2, what would be my answer? 12 point. 12 point what? Yeah, it would round down because the next number is a 4. 12.12. Exactly. And now, what I'm going to do is I'm going to put this symbol. Has anybody ever seen this? What does that mean? It's a little different than an equal sign. Anybody know what it means? It means that that's about what my answer is. That's not exactly what it is. That's not even exactly what it is. Okay? We rounded it off. So we don't have an exact answer for this problem. Now, they didn't ask you if it was a Pythagorean triple. But if I did ask you, is this a Pythagorean triple? What would you say? No. You had a decimal for one of your sides. That is not a Pythagorean triple. Nope. Okay? Right. Any questions on that one? Okay. Do you guys need to see another one with the finding the leg? Seems okay. All right. Let's go to example 3. Okay. This one's a little different. It's actually a 2-step problem. It says find the area of the triangle. Bless you. Now, before we even think about Pythagorean theorem, I want to think about what the formula is for the area of a triangle. Okay, and there's a box on your reference sheet. We're going to write that in. Does anybody remember what that formula is? Area of a triangle. Logan, did you think you had it?
As a fraction.
Base times height is the area of a rectangle. What if I give you a hint? Here's a rectangle, and I cut it in half. Now I have 2 triangles. Does that give anyone a hint? Area, it's 1/2 base times height. Okay, so if you didn't know that, make sure on that box where it says area equals, put in 1/2 base times height. So that's an easy formula to use, but I'm missing something. In the problem I gave you, in order to use this formula, I need to know the base and I need to know the height. Which one don't I know? Yeah, I don't know the height. That's the problem. If I knew the height, I could just plug in h, I could just plug in for the base, and I'd be done. Okay, but we don't know the height. So what theorem do you think I can use to find the height? This is what we've been working on today. About Sam? Well, that's how we're going to get the area of the triangle, but the problem is we don't know the height. Pretend they didn't ask you for the area, and I just said find the third side of this triangle. How would you figure out the third side of that triangle? Oh, Ben?
You would write 5 squared
Yep,
plus h squared
I like it.
equals 7 squared.
Equals 7 squared. What theorem did you just use?
The Pythagorean theorem.
Yeah, he just used the Pythagorean theorem. Okay? He's going to find the third side of the triangle first, which happens to be our height. And then after we know the height, then we can figure out the area of the triangle. Okay, so for now, forget about the area of the triangle. Don't worry about that. Just find the third side. Okay, do that first. Okay. Any questions on why the 7 had to go by itself and why the 5 went on the other side? Okay. Always put that biggest number by itself. Okay, always. How about Alex? Can you tell me what 5 squared is? 25. Now, when you have the letter, just leave the letter. Nothing you can do with it right now. And how about 7 squared? Oh, Corey, what's 7 to the second power? Seven times 7? Yep, 49. All right, now this is the one where you have to get this by itself. Anybody tell me my next step to get that h squared by itself?
Minus 25.
Yep. Okay, we got a minus 25 from both sides. And we get h squared. Now let's do 49 minus 25. 24. So does that mean the height of my triangle is 24?
No.
No. I got one more thing to do.
Divided by 2.
No, don't divide by 2. Take the square root.
Last step, guys, last step, every Pythagorean theorem problem, whether you have to solve for a leg or whether you solve for the hypotenuse, the longest side, you have to square root it. You have to. Every time. Doesn't matter what you're trying to find, you have to square root it.
Okay, so that gives us a height of about, let's round it to 4.9. Okay, so there's our height.
Gage, is that a Pythagorean triple? No. How do you know? Why is it a Pythagorean triple? Yeah, guys, it's a Pythagorean triple when it does not come out to a decimal. It comes out to a nice answer. If it comes out to a decimal, not a Pythagorean triple. It's that simple.
4.8.
Yes, I rounded it. Yeah, there. Now, is this our answer, 4.9?
No.
Is that what the question wanted? Right. The question didn't say find the height. The question said find the area. So now, what do I do with this 4.9? Where does it get plugged in?
To the formula.
To the formula. I'm going to plug it in for h. What's your base, though? What number in that triangle is the base? Yeah, the base is the one that's on the bottom. Okay? The 7 is the hypotenuse. That's your base. Okay? They put an m after it because this is measuring in, I think they use meters. All right? So now let's fill it in. 1/2. The base is 5. Logan, what's my height?
4.9, right?
4.9. And now just use your calculator, type that in, and see what you get. Okay, we got 1/2 times 5 times 4.9. Okay, you can type it all in at once if you use parentheses around 1/2. Okay, so we get kind of a nice answer, 12.25. And what should my label be? Okay, the lengths were in meters, but this is an area. So what do you put for a label on an area problem? Yep,
Meters squared.
perfect. Square meters, or meters squared. Yep. Okay, if you forget that label, you'll lose 1 point. Okay, for the problem. So remember, if you measure something in area, it's meters squared. Just think about if you were putting in a new floor. You measure it in square feet, right? You need to know how much tile to put in like a bathroom. You say, oh, I need 20 square feet of tile. You don't say I need 20 feet of tile. It's measured in square feet. Or square yards, sometimes if you have a really big room. Okay. Any question on how we found the area? A little tricky, 2 steps. You got to find the height first, and then you can find the area. All right, last problem. Okay, and this one I think you guys already have it written what the problem is on your sheet. You guys got the diagram on it too? Yeah. It says the skyscrapers shown below are connected by a skywalk. Okay? And it says use the Pythagorean theorem to find the length of the support beam. All right, so let's take a look at our picture. Okay, so what's shaded in light gray? Those are the 2 towers. Okay, this beam going left to right, that's the skywalk. Okay, how many triangles do you see in that picture that have the little symbol, that little 90-degree symbol? Yep. 2. Yeah, you've got 2. You got one right here, and you got one right here. Now, they want us to find the length of each of the supports. Okay? These are the supports that are supporting the skywalk. Watch what happens if I take this red triangle and this red triangle, and I compare them. How do these 2 triangles compare to each other?
They're the same, unless they're just opposite.
Yeah, if I take and just kind of flip it around, I didn't draw it perfect, but they really are exactly the same triangle. Which means, once you find this, you automatically know that. So you only need to do it 1 time. Okay? Because these are the same thing. All right. So what I like to do is take, okay, there's our triangle. I like to draw a triangle off to the side. All right? Just so I don't have to look at all the other stuff. Okay? And I'm going to try to label what I can. Okay, Logan, what can I label in this triangle? Well, you need to pay attention. I'm sorry. What can I label in this triangle?
90 degrees.
Okay, got that 90 labeled, yep.
You run the hypotenuse.
Okay, the hypotenuse, what could we label that as? X. All right. What else can I label?
You could label the leg, one of the legs like 23.26.
Yep. Okay, they put it in right here. One of the legs of the triangle is 23.26. Already, if I asked you, is this going to be a Pythagorean triple? What's the answer? No, you already have one side that's a decimal. It's not Pythagorean triple. Okay, and there's one more thing I can label.
The other leg.
Yep, the other leg is 47.57. Okay, now, what's the name of that theorem I'm going to use to find the length of the support for the skywalk? Okay. What's the name of that theorem we're going to use to find the length of the support for the skywalk? Yeah, we're going to use the Pythagorean theorem. Okay? Really, all you're doing is finding how long the hypotenuse is. The hypotenuse is the support for the skywalk. That's it. Okay, so let me bring it down where I have a little bit more space. Okay, last thing I need to do is just set up my equation. Can anybody set up my equation for me to solve for x?
Would it be 23.26?
23.26
Squared
squared, yep.
plus 47.57 squared
Good, I like it.
equals 30 squared.
Perfect. And now, numbers are going to be a little messy, but we'll just do it out, use our calculator. 23.26, square it. 541 point, if I round to 2 decimal places, what would that properly round to? Point what? 541 point. About Ryan? That round to.
Is 2. I mean, 0.02 or,
Nope, not 0.02.
oh,
Remember, rounding is different than just chopping off the numbers. When we round, we have to follow rules when we round up or when we round down. So would this 2 round up to a 3? Or would it round down to a 2?
up to a 3.
Yeah, okay, because the next digit is a 7. We're going to round up. Okay, so make sure on the test you round, if they ask you to round properly. 541.03 plus, okay, now I need 47.57 squared. All right, who can tell me what that would round to?
Wait, how did you get 541 again?
We just took 23.26 and squared it.
Oh, okay, yeah. Okay.
Okay, so 47.57, that's going to round to 2,262.9 what?
Is that 8 next to it?
Let me make it a little bigger so you can see it.
Should be 9,000. Right?
0.9, and then just a number.
Wait, what?
It's going to be 2,262.90. Okay, that time,
Oh.
because the next digit is a 4, that 0 just, it rounds down. So 2,262.90. Okay, these are kind of big numbers, but when you're working with a real big building, like skyscrapers, I would probably expect the numbers to be kind of big. What's the next thing I do with these two numbers? The 541 and the 2,262. Add them up. Okay, let's take 541.03 plus 2,262.90. 2,803.93. Now that's not the length of the support. One more step I got to do. Careful, not square, but what? Square root, like Mr. Roy said. Last step, always take the square root. The square root cancels out that square. And let's see what we get. Square root of 2,803.93. Do you think it's going to be a bigger number than 2,803 or smaller? Yeah, when you take the square root, usually the number gets smaller. 52.9. Well, you tell me. What would that round to? 52.9 what? 95. This time it would round down, wouldn't round up. Okay, I always like to go back up, make sure if they had a label, I include it. And I blocked part of it, but they had a label of meters. Okay, so just make sure you put meters. Right, so that's a pretty long steel beam. Okay, if you were to put that on a football field, that would probably go from like the end zone to like a little past midfield. It's a pretty long steel beam. Okay. Hey, any questions on that? All right, so you guys got about 10 minutes left. Okay, so we're going to pass out the reference sheet, give you time, a little bit of time to start it, ask us questions. Okay, and okay, don't forget, tomorrow we have a quiz.
How many questions you got?
Quiz tomorrow, Mr. Roy, how many, 8 questions, I think? Actually, I probably didn't show you. I think it's eight questions. Quiz tomorrow, 8 questions. And the periods are, just to remind you guys, 4, 5, 6, 1, 2, 3. So we'll see you guys like 12:30 to 2, right in there.